We were discussing ligands in the last class. If you remember, I told you that ligands are electron pair donors, right? Just like a nucleophile. If you remember from AS, okay, we used to discuss the term nucleophile, right? We used to discuss the term nucleophile. Nucleophile were having negative charge, but it doesn't mean that the negative charge is must on the nucleophile because what's the condition? What's the condition for the nucleophile? Basically, they are supposed to have a lone pair of electron. If they have, so yes, they can donate their lone pair of electron. Same goes for the ligand because sometimes we don't have, uh, sometimes we don't have, you can say the negative charge, right, on the particular species. So, so then we have to see, is there any lone pair of electron? If yes, so yes, it can behave as a ligand, otherwise not. You can see ammonia and water. Ammonia doesn't have any charge, but it can act as a ligand. You know why? Because ammonia is going to have a lone pair of electron. So that's why it can act as a ligand. Same goes with the, I can say water. Same goes with what? Same goes with water. Because water also has a lone pair of electron. So when water also has a lone pair of electrons, since water has two lone pair of electrons, ammonia has only one lone pair, but water has two lone pair of electrons. So yes, I can say water can act as a ligand as well. Then I told you there are two types of ligand, okay, negative ligand and a neutral ligand, okay. Then I told you on the basis of donation of electron pair, we can classify a ligand into three categories: monodentate, then bidentate, then polydentate. Monodentate means those which can donate only one lone pair of electron, just like ammonia. So these are monodentate ligands, okay? And then we have a bidentate ligands. Bidentate ligand means that they are going to donate two lone pair of electrons. Example is C2O4 2 minus EN, ethylene diamine. Then I told you about the polydentate ligand. What is polydentate ligand? Which can donate more than two lone pair of electrons, right? It may have three, it may have four, it may have five, it may have six. So by the way, in fact, EDTA is going to have six lone pair of electrons. So that's why I'm saying that it's in the category of a polydentate ligand. Okay. Uh, this is the structure of EDTA. You can see in this structure we are having, let me draw the structure of EDTA. You will see that this is going to be nitrogen. This is CH2 and then I have CH2, then again I have nitrogen. Okay. Or nitrogen is attached with the carboxyl group, that is C double bond OO. Again the same thing, C double bond O, then O. Then again the same thing, C double bond OO. And then again the same thing, C double bond OO. Then I can write down the lone pair of electrons. So you will see that it can donate one, two, three, four, five, six lone pair of electrons. So yes, it is a polydentate ligand. Okay, so you need to memorize this. Okay, because when the examiner would be asking to find out the oxidation number of a particular metal in a transition metal in a complex compound, so then you need to know the oxidation number of a transition metal. Okay. So before going into the detail of a complex compound, we are discussing few basic, you can say, terms. Like I told you about the ligand, then I told you about the complex, what the complex is. As I told you, complex is a combination when the metal reacts with a ligand. Of course, metal is going to have a positive charge and a ligand is going to have a negative charge. So when they will be reacting together, so they will be forming a complex. And then I told you the categories of a ligand: mono, bi, poly. So now we are going to discuss what is coordination number. Okay, what is coordination number? Coordination number means that when ligand is going to make a dative covalent bond with the metal. Sometime ligand forms one dative bond, sometime ligand forms two dative bonds, sometime ligand forms more than two dative bonds. Okay. So what is coordination number? Let me tell you this. Co coordination number. So coordination number, I can define it as uh, the number of dative bond between the metal and a ligand. Okay. So uh, number of number of dative bond number of dative bond formed by a ligand. Number of dative bond formed by a ligand. Okay. So sometime it can make one dative bond, sometime it can make two dative bonds, sometime it can make more than two. Formed by a ligand. As I told you, this example, this is the first dative bond, second, then third, then fourth, then fifth, then sixth. Okay. So what's the nature of water? What's the nature of water? It's a monodentate ligand. You know, it's going to share its one lone pair of electron. That's why it's in the category of monodentate ligand. Since it has no charge, so it's a neutral ligand. Okay. Since it doesn't have any charge, so it's a neutral ligand. So in this way, we can determine how many dative bonds would be formed between the metal, or I can say in between the ligand. So then after coordination number, examiner will be giving you the complex compound. Okay, examiner will be giving you the complex compound and will be asking to identify the coordination number. Let's see, as I'm giving you this compound, let's say I have copper, then En, and then 3. Copper, En, and then 3, and this is plus 3, right? This is plus 3. So I can say that if I'm asking to write down the coordination number, so what will you say? If I'm asking to write down the coordination number, since we know that this is a bidentate ligand, since we know that this is a bidentate ligand, since we know that this is a bidentate ligand, so each ligand is going to make two dative bonds. So how many ligands you have? So 3 multiplied by 2 is equal to 6. 3 multiplied by 2 is equal to what? 6. So I can say that the coordination number would be 6 because En will be making 6 dative bonds. Because En will be making 6 dative bonds and that's it. Okay, 6 dative bonds and that's it. Right? So it's a very easy to determine. Let's say I'm asking copper EDTA. Let's say I'm asking copper EDTA and the overall charge is 2 minus. So what's the coordination number? Since we know that it's a hexadentate ligand. So hexadentate means I can say that only one ligand you have, it can make 6 dative bonds. So 6 ones are 6. So the coordination number is 6. So the coordination number is 6 and the coordination number is also 6. Hopefully you are understanding what I'm telling you. So in this way you can identify the coordination number. Okay, good. Then I can say, uh, let's say I'm going to give you this one. Let's say I'm going to give you this one. Nickel, then I have nickel, then I have cyanide 2, and then I have NH3 2. Then I have NH3 2, right? So what would be the coordination number? So what would be the coordination number? What would be the coordination number? So how can I say? So since we know that it's called mono, it's a monodentate ligand. Again, it's a monodentate ligand. So we have two mono mono. So means 2 plus 2 is 4. So the coordination number is 4. Mono mono is 4 since so that's why the coordination number is 4. Okay. Simple and simple and simple. Or else, let's say I'm going to give you this structure. Can you tell me this one? Chromium, and then Cl2, and then H2O4. Can you tell me what will be the coordination number of this one? Yes, 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 yes. Mhm. What will be the coordination number? Yes, past, past. It's very easy. Why are you taking time?
Sure, is it 6?
So what you are saying?
6?
6. So I can say that if this is a monodentate, it's going to be 1. So 2, like 2 chlorine we have. H2O is also a mono. It's going to make 4 covalent bonds, dative bonds. So 4 plus 2 is 6. So the coordination number is 6. Okay. It's a baby topic. It's a baby topic. Or, let's see this one. Let's see this one. Fe, FeC2O42 minus. Yes. So this is going to be 3 and the overall charge is minus 3. What do you think? What would be the oxidation, oh, sorry, coordination number? Obviously, you are thinking, sir, what's the type of ligand in this one? Obviously, you are thinking about the type of ligand. So I'm telling you that this is a bidentate ligand. I'm telling you that this is what? I'm telling you what? This is a bidentate ligand. So each ligand is going to make two dative bonds. So since we have three ligands, so obviously three ligands would be making six dative bonds in total. So I can say that coordination number is 6, isn't it? Right? So, yep, this is a bidentate ligand. It's a bidentate ligand, right? So means that 3 multiplied by 2 is equal to 6. Again, I can say coordination number is 6. Now, it's your turn. Now it's your turn. You're supposed to tell me, okay? Yeah, see this? Can you tell me? Can you tell me this one? Can you tell me this one? Yes, 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 yes. Mhm, mhm. Yup, it's very easy. Fast, fast. Mhm. This is, by the way, bidentate ligand.
6.
Good, 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 good. This is six. It's a bidentate, right? It's a bidentate. Good one. Now, how to find oxidation number? How to find oxidation number in a complex? Okay. Yes, 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 yes. So let's say I'm gonna tell you that it is going to be FeCN6. Can you find out the charge on iron? Yes. Find oxidation number of iron. Let me tell you first, then you are supposed to solve, okay? Iron is unknown. This is going to be X. We have 6 cyanide. Since cyanide is going to be -1 is equal to +3. I have to calculate X. 6 ones are 6. That is going to be -6 is equal to +3. Then it's gonna like that. Sorry. The overall charge is -3, not +3. Okay. So it's going to be -3. Answer is +3. Okay. In this way, you can find out the oxidation number on a particular metal. In this way, you can find out the oxidation number on a particular metal, and that's it. Okay. Easy. It's very easy. Or let's say I'm going to give you this one. Let's say I'm going to give you this one. Can you tell me the charge? Yes. Okay. This is Fe. Yes. Again, the same question, but please fast.
Plus 3.
Plus 3. Okay. Let me check this. Iron is X T into minus 2 because this is having a minus 2 charge is equal to minus 3. Okay. It's very easy. It's very, very, very easy. Okay. So there would be a lot of questions related to this one. Okay. There would be a lot of questions, you will see in paper 4. Let uh, let's do the question. Let's do the question related to the charge and coordination number and these all of that stuff. Yeah, see this one? Transition elements. Okay. 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 Yep. You have to complete it. You have to complete it, okay? I can only give you 2 minutes. Then I would be telling it to you. Start. Okay, now I'm solving it. You are supposed to match. If this is matched, so that would be good. Okay. So first of all, I can say that the formula, the charge of the complex is -3. So I can write down the formula Cr and then Cn. The overall charge is -3. Okay. Since we know that the overall charge on a chromium is +3, so how much cyanide should we add? Since we know that the cyanide is going to be monodentate ligand, so it should be 6. So when it should be 6, so -6 and +3 gonna give you -3. Yeah, that's it. And the coordination number is 6 because we know that cyanide is a monodentate ligand. If we have 6 cyanide ions, so means that the dative covalent bond would be 6. Okay. And then they have told you the coordination number, but we know that it's a bidentate ligand, but we know. So I'm going to use a short term that is En. This is En. This is En. We know that. I'm supposed to write 3. Don't write 6 over there. You know why? Because this is bidentate. Each ligand is gonna make 2 bonds. So there would be 3. So 3 into 2 is 6, isn't it? And it's a neutral ligand, so that's why the overall charge would be nickel. So that's going to be +2. If you are having any issue, so do let me ask. So do ask, okay? Otherwise, it would be very difficult for you to catch this one later on. So it's the right time to ask the questions. Then I am supposed to write the formula platinum and Cl. Since we know that the overall charge is 2 minus, and also we know that the charge on platinum is +2. How many chlorine I'm supposed to have to get -2? Of course, 4. Of course, 4. So the coordination number is 4. Since chlorine is a monodentate ligand. So -4 and +2 gonna give you -2, isn't it? Then for the last one, Fe. Since we know that this is a bidentate ligand, so 3 ligands means that the coordination number would be 6. And since it's gonna have -2 charge, so -2 means -2 and I can say that -2 into 3 is -6 and iron is +3. -6 and +3 is gonna give you -3. Okay. Let me solve it. See this. Iron is +3 and it's gonna be 3 into -2 is equal to, we have to find out. So it's gonna be -3. Got it? Wrote -3. In this way, the examiner would be asking. In this way, the examiner would be asking to write down the overall charge, to write down the coordination number, to identify the ligand, to identify the metal cation. So a lot of questions you will see related to this. Not only this, but also find out you have to identify the ligand, which can be a ligand and which is not. Let me tell you the question related to that. Yep. Yeah, this one. Yes. Can you tell me this one? Can act. Yes. Negative charge. Cannot act. BF3 can act. You are thinking that, no, sorry. No, it cannot act as a ligand. You know why? Because boron has no electron pair. You can write down the dot and cross diagram. You can draw the dot and cross diagram. Boron doesn't have any lone pair of electron. If you remember the dot and cross diagram from the AS level. Of course, you need to know this one as well, You must know this. And I can say, yes, because it has a nitrogen, it has a lone pair of electron, right? And no. Okay. Okay. because ammonium positive means that there is no electron. For so uh for a ligand they must have a lone pair of electron. Okay, everything is quite clear. Everything is quite clear. Okay, it's very easy. It's very easy, right? Or okay. So there are other questions as well. So yeah, you can see this one. Can you tell me this one? Yes. Can you tell me this one? Hmm. Yes. What do you think about OH minus? Is this a ligand? Yes or no? Yes or no? Yes or no? Fast. Hmm. Umar, Sufia, Shamir, Zainab, Aliha, Vinod. A lot of people are here, but no one is replying. Why? Yes.
Oh,
Yes. Because it has a negative charge, isn't it? It has a negative charge. So that's why it can act as a ligand. Okay. So that's why it can act as a ligand. Okay. Or what can I say? Or what can I say? Like so ammonium. No, ammonium has a positive charge. Positive will not act as a ligand. Positive will not act as a ligand. Okay. And what do you think about this one? CH3OH has an oxygen atom. Oxygen is going to have a lone pair of electrons, so that's why it can act as a ligand. Okay. So then we have CH3NH2. Yes, it has a nitrogen atom, and nitrogen is going to have a lone pair of electron. Yes, it can act as a ligand. Okay. So it's very easy, right?